Okay, today we're going to talk about types of hydrocarbons. There's two different ways that you can categorize each hydrocarbon that you look at. And the first way is by shape. So does it look like this? Or does it look like this? This type over here, they're called straight chain. Which simply means that all the carbons are connected in one line, one to each other. And these over here are called branched chain. Okay. This week, we're only going to look at the straight chain ones. We'll come back to these. This will be the focus of next week. But right now, we're going to look at our straight chain hydrocarbons. What do we call them if they're all just in one line? Now, one thing we need to watch out for is that these bonds can bend and turn, that these don't have to sit rigidly in one neat, straight, perfect line. This is more like a chain of beads. This chain and this chain right here are exactly the same thing, and this chain right here, all of those are exactly the same thing. It's just I've taken this string of 4 carbons and kind of bent it and twisted it around a little bit. Like taking a string of beads and like putting it in a pile, it's still the same string of beads in one straight line. Okay, in order to get to here, I would have had to actually taken one off the end and hooked it somewhere completely different. Okay, so these are a straight chain. Okay, the next category, the one that we're actually going to look at the differences between, because we're going to focus on these straight chains. The one that we're going to look at the difference between today has to do with the types of bonds. Okay, things that have all single bonds. Okay. Any compound that's composed of entirely single bonds is called an alkane. Anything that's that contains double bonds is called an alkene. And anything that contains triple bonds is called an alkyne. Okay, so what you're going to look at is how we name these different straight chain hydrocarbons. So in the classroom, the worksheet that you're to fill out today asks you for the name and the molecular formula for each of our hydrocarbons. And I give you prefixes. The prefixes, and they're in the on the worksheet, okay, are based on how many carbons are in the molecule. So 1 carbon, we use the prefix meth. 2 is eth. I'm only going to give you the first few here. 3, because I want you to be able to pronounce them. So 1 is meth, 2 is pronounced eth, 3 is pronounced prop. It's not prop, it says prop. Okay. And 4 is pronounced bute, not but. Okay, that says bute. And from there they get easier, right? There, if you open it up, you'll see that their 5 is pent, hex, hept, oct, non, dec. They're prefixes that are familiar to us. Okay, but these first 4 are a little bit new. Meth, eth, prop, bute. Now, if there's only 1 carbon, it can't be double bonded or triple bonded to anything. So the only meth hydrocarbon we have is methane. Okay, so we take, I got ahead of myself. We take these endings right here. Those are our suffixes. These are our prefixes. So a compound that looks like this is ethane, because it's got a single bond and 2 carbons. And a compound that looks like this is ethene. ene, and one that looks like this is F ine. Okay, so your assignment today is to go through and make all the names and then find the molecular formulas for these. Now, one thing that I need to point out, we're assuming that there's only one double bond in each molecule, and when you get something a little bit bigger, like say butene. Okay. You'll find, let's scoop that up, okay, that it's got 4 carbons, 2, 3, 4, okay, and because it's an ene, it's got to have a double bond, or where are we going to put it? I could put it here, okay, or it could look like this, right? Hypothetically, it could look like this too, right? But what we're going to find next week is sometimes things are drawn differently, but are the same thing. Like back here, right? These 4 things are all drawn differently, but are actually the same thing, just bent and twisted. This and this are the same thing, it's just I've picked it up and flipped it over. That doesn't change what the molecule is, it's still the same molecule. So this really is not an option because it is exactly the same thing as the one above it. So I could have it in 2 different places. We are not going to care today. These 2 things will have the same molecular formula. So for our case, it really doesn't matter. All I want is a name, put a double bond in it, and tell me the molecular formula for that. It'll end up with the same molecular formula no matter where you put the double bond, as long as it's all straight chain. Actually, it doesn't matter there, but it'll still work out the same. Okay, so there's a lot of typing. It seems like there's a lot of writing. If you would like to shorten your molecular formulas instead of typing in C4H, this would have 1, 2, right, 3, 4, 5, 6, 7, 8. Instead of typing in this, if you just want to type it in as 4, 8, that's fine too, if that saves you some time. But otherwise, that's all we're looking at today. Okay, key to the lesson. Single bonds are alkanes, double bonds alkenes, triple alkynes. We take the prefix for the number of carbons and put the suffix for what kind of bonds it has. So propyne would have a triple bond, whereas propane would have all single bonds. Okay? Fairly straightforward. Good luck.